Another effect that you have to be aware of, and that one is easy, is reflection. Reflection is when your wave changes direction, not because going through material, but just because of bouncing on something, like this mirror here. With light, that's pretty easy, right? You see the sky, and you see the light going in my hand and burning my hand. So that's because the light is reflecting on the mirror and just going another direction and not going to the ground anymore. That's something you know and you've seen every day. So there are a few rules you have to be aware of for reflection. One of them is that the angle of reflection is identical to the angle of arrival. So what does that mean? Is that if you take my mirror here, my gray surface, and you look at my angle of arrival of my wave on the left, the reflection going back on the right is going to be exactly the same angle compared to the gray surface or compared to a 90-degree imaginary line in between. So that's going to be always exactly the same angle. That matters to us because that means that we know where the reflection is going to go. So that's important. Second thing, which is more of a detail, is that not all surfaces are going to reflect your wave, and it's very much dependent on the frequency of your wave. Some material may be reflecting light and maybe letting going Wi-Fi through without any problem. Some material may be reflecting Wi-Fi and may not be reflecting something else. So your reflection material is going to be related to the frequency of the wave you're sending. In Wi-Fi, carpet typically do not reflect too much. Furniture, anything metallic, walls, ceilings, all that typically reflects some of Wi-Fi. But there is always a tiny bit of energy that is going to go through, that is, it's not going to be reflected. So that's what you see depicted here with this tiny arrow. Most of the energy is going to reflect, some of it may be going through a little bit. And that may create some effects where you have a wave hitting a wall at an angle, and then some of this energy is going to go through that wall and you'll still be able to detect that energy on the other side, while most of the energy is going to reflect on the wall. The amount of energy that is reflected compared to the amount of energy that may be going through is going to be dependent also on the material and the angle. So what you see on the right side is my wave hitting my wall exactly, boom, 90 degrees. In that case, most of the time, what is going to happen is that the wave is going to go through. It may be absorbed, that's one thing, but it's typically not going to bounce so much. You need an angle to have the wave bounce back. So that angle plus the material is going to determine how your wave is going to bounce on material. So you see, reflection is complex. It depends on the angle, one. It depends on the material, two. And also it depends on the amount of energy that you send. That's going to be determining how much of it is being reflected and how much may be going through. But again, you need to be aware that reflection is going to happen. And it's going to be damaging in Wi-Fi, so we need to be aware of it. And one effect of this reflection is when it bounces on multiple obstacles and gets to the receiver. If you look at my wave here, my intent is to send from that access point that you see on the upper part of the screen a signal to the laptop. And when that wave is sent, of course, my antenna is not going to be able to shoot a signal like a laser to the laptop. It's going to send a signal, it's going to spread around, and it's going to bounce on walls. And as it bounces on walls, part of the energy is going to go straight to the laptop, and that's the main signal. But part of the energy is going to bounce on ceiling, on furniture, on walls, and whatever is in the room, and maybe getting to the receiver at a delayed interval. And you get that sort of potato wave shape that you see on the right. That effect where the wave takes multiple paths to eventually get at the receiver is called multipath. It is a very important phenomenon in Wi-Fi. Up to 802.11n, it used to be a major problem because multipath would render the main wave altered by these echoes coming back later and making the main wave more difficult to understand. With 802.11n and 802.11ac, but we'll cover that more in detail, we actually take advantage of those reflections to compare differences between two antennas and be able to send more than one signal at a time because we can know how different they are on 2 points in space. So with 11N and 11AC, multipath may still be a problem if there is too much of it, but we need a little of it to be able to be more efficient with Wi-Fi. So we take advantage of multipath instead of suffering from it.